Okay, so I think that's pretty much it. So I'm going to be doing a talk on SQL Server and continuous integration. So I suppose the first thing really to say is like what is this? What is continuous integration? What's it all about? And why do we bother? And I know. So I suppose first of all, who here is a DBA developer, or a SQL developer, app developer? Right, so it's a real mix. So I mean, if you're a DBA, this sort of thing normally applies to developers. Developers build write their code and have development pipelines and continuous integration. But it's really about releases. What we're doing is we're making releases, more professional, we're making them more reliable. So that that it helps DBAs. So whether you're a DBA who says, we're actually going to write the code and set up the pipeline, or if you're going to go back to your developers and say, actually you need to start doing things properly. And what I want to do is start seeing like automatic generated scripts. I want to start seeing unit tests. I want to see more reliability. Now, when it comes to releases, I don't know who's sort of familiar with like the traditional approach to releases of going, we've got a release next week, so someone has to gather all the scripts together. I've got to send 4 scripts over here. Maybe I've got to send a couple of scripts over Skype. But the script named like 1, 2, 3, I shouldn't be running that script. I should be running the one that's like 400k instead of 600k. It's a really sort of ad hoc process of managing releases, and it leads to reliability issues. It leads to a lot of like worry over doing releases. We're going to do a release, and is it actually going to work or not? So it's really about making releases faster, making them more reliable, and then to support this. So what we're going to start doing is we're going to start saying, okay, so a release is going to be instead of this like ad hoc method of gathering together all these scripts, we're now going to phone up the DBA and say, right, we want you to go and release the scripts from build number 712. So the DBA goes to that folder, he picks up the scripts and he runs them. So there's none of this sort of, right, quick, we've got to gather our scripts, we've got to spend half a day, whatever it is, getting all the scripts together. Now becomes a lot simpler for everyone involved. But to support that, it starts to be, there's like a certain amount of risk. We're not having someone look at all these scripts and get them all together. We're now sort of trying to trust our tools to do the scripts for us. So what we need to do is we need to have like unit tests, and we need to have integration tests as part of this. So we need to say, when we have a script generated and when we have a script we're going to deploy, we need to make sure it's well tested. And once you start to do this, once you have a full set of unit tests and integration tests, you can start to say, actually, it's not just about writing code and getting it out. It's about writing code that we can trust. Once we start trusting the tools and start trusting our code, we can then do some more interesting things. Like normally you create a database, and then a couple of years later, someone makes some changes to it. Maybe the BI team get involved. They don't like normalising their tables, so they shove in a table, add a few columns on here, which really shouldn't happen. But you can't go and tidy up the code. You can't say, we've got some issues here, we want to make some changes to the database and tidy it up. Because you haven't got any unit tests, if you've got to make a change here, you don't know what it's going to affect. But if you've got a full set of unit tests and a full set of integration tests to support the sort of CI process, you also get this sort of other ability to go and make changes, to tidy up code, to make it better as you go along, rather than sort of staying away from it and going, we'll just have to live with it being a bit rubbish. So that's the sort of the main reason why we bother doing this, and why we bother doing this, creating a CI process. I'm going to show you how to do this with SSDT, but the tools don't really matter too much. You can use any tools you want, as long as you can sort of automate them and you can remove the sort of the human factor from making mistakes. Because if you have releases and you have your releases driven by this sort of process, it removes the human factor. And humans make a lot of mistakes. I'm going to make mistakes every day. So if you've got this sort of process, it just makes it better. So does everyone agree that CI is a good thing? Yeah? So who today has got their databases under source control? So that's a few more than I expected. Normally say who's got their databases under source control. People go, not me either, no one. So who's got CI for their databases set up? Okay, and who wants to? Who wants to do this? Yeah? Right. We'll ask at the end, and everyone's got to go, yes, we all want to. Whether you do or not, I don't know. So a little bit about me. I've worked as sort of a real mixed background. So I worked as support, worked as a DBA, worked as a development, and then so I've worked with SQL since about 2005 with SQL 2000. And a few years ago, I went off and I worked just doing C# code, working in a very agile team focused on writing clean code, how we improve our processes, how we do things like CI to improve the quality of the code we produce. And then I came back to working as a SQL developer. You know, SQL developers have more fun, that's certainly true. And shocked really, so you go and ask people, okay, where do we get the code from source control? Where's the CI processes? And they're like, no, we don't do that. We just we write these scripts over here, we generate and we throw them over there. Maybe in some shops they use like the Redgate tools like SQL Compare, but more often than not, it's just we use none of these tools. So I sort of spent like the last year and a half trying to get people to start using source control and saying, you know what, we can do better as a community of SQL developers. Let's start using these tools out there because we've got this tool SSDT. It's a great tool. It doesn't cost any money, and we can build all this sort of complete CI pipeline. But it's just having this sort of mindset of going, what tools we've got available. Let's start using them rather than sort of sticking with what we've got today. So, you know, it's 2015, I think, yeah, it's 2015. As developers, we've got choices as to what IDs we use. So, who writes all their code in SSMS? Who writes their code in Notepad? I learned C using Notepad a bit. I think it's good, but that's quite a while ago. Has anyone heard of OXDBE? There's a JetBrains tool. The people who make ReSharper and IntelliJ, they've got a UI, and that's actually a really good UI for developing SQL code. If we didn't have SSDT, I'd be using that, and I was using it for a while. So if we start with SSMS, SSMS is a great tool for managing SQL Server. It doesn't have many features for developing SQL code. Right? I think one of the best features it's got is when you run a script and you've got the statistics, and then if you run a script multiple times, you get like different columns to show how your script's improving or getting worse over time. That's about the best use for SQL Management Studio. If you're using it to look at execution plans, there's other tools like the SQL Sentry. You use the SQL Sentry Code Explorer. There's a free version of that. Use that over SQL Management Studio. Now, so I suppose, what is it about SSDT that makes it useful for us? What can we do with it? Well, so there's different parts of SSDT. So first of all, there's the actual development UI, and there's some features in that, like you can, if you want to go to a stored procedure, you can just shift and click and go through to that stored procedure, go through to the definition. You don't have to go through like Object Explorer and sprint out the object. You can just go straight to it. And one of the best features, and I think for me it's really the killer feature of SSDT, is that if you've got a table or column or schema, whatever it is, that you want to rename, so you want to say, you know, all of our tables, they have an ID field that's always table name _ ID, but this one developer, he's added just ID, so it's confusing for everyone. If you use like the Redgate source compare to deploy changes, if you rename that, what will happen is when it goes to create the deployment script, it will say, okay, in our source, we've got employee _ ID, and in our destination database, we've got ID, so we'll have to drop the ID column, we'll have to create a whole new column, then you've lost all your data. So with SSDT, what you can do is you can right click on it and go rename, refactor rename, with a shortcut to do it. And if you use SSDT to do it, first of all, it will rename all the other pieces of code that point to that column or table or schema. And then when it goes to create the deployment, it will generate an SP rename for it. So you don't have a situation where you're going to lose a column. You've got a situation where you can start to make changes. You can start to improve the code. You make sure your schema is correct and it's nicely named, and not risk losing data. So for me, that's one of the killer features of SSDT. But it gives us more, you know. So when you have an SSDT project, as in Visual Studio, when you build it, it's not like a C# project where your output's DLLs and exe files. There's this thing called a DAC pack. Does anyone know what a DAC pack is? Yeah, there's a few nods. So a DAC pack's basically a zip file with the contents of your SQL in. And what happens is when you go to, when you've got a DAC pack, you can use that to compare that to a database and create a deployment script. So you don't have to manually create deployment scripts or upgrade scripts. If if you want to change the version of store procedure, you just put into the SSDT project what it is you want the store procedure to look like, and then it will take care of doing an alter on anything that needs to change. So that's really useful. Now, SSDT also comes with this API. So if anyone's knows any .NET language, you can use this API to query the DAC pack or to query tSQL and create your own .NET apps to do stuff. And I mean, it sounds like why would I bother doing that? But I mean, there's one example. We had a project which, for some inexplicable reasons, we had one big deployment script which inserted into a whole load of tables, and we had to split the database into two. And it would have taken someone all day to go, okay, this script is for this table, so put this into this project. This one's for this table, put it into this one. So what we did is we used the DACFX API to query the text and say for each statement, go and find out what table it's querying and wrap it in an if exists statement. So instead of it taking sort of all day and probably being wrong in a couple of places and being a real pain, it just took a couple of hours to do that, and we could use that and we could use it again. So it's a really nice thing that we can start to do more than we can do today by using this this free tool. Is everyone convinced about SSDT? We'll go with this, right? So the first step we need to do is we need to take our code and we need to get it out of SQL Server database, and we need to put it into text files, basically, like .SQL files. So when we start to work with source control, we can take our database, we can take a backup, or we can take our MDF files and we can check them into source control. But I don't know if anyone's ever tried to do a compare on that. I did it for a talk I did before, just as more of a joke to see what happened. And you basically you're comparing completely different binary files. You've got no sort of tracking of history, and it's difficult to compare things. It's basically like the worst thing ever you could do. So what we want to do is we want to stop the files just being in SQL. We want to get them into text files where we can start to work with source control systems. So I've got some demos. What we'll do is so I've got a development instance of SQL Server. Now I'm going to just for the sake of the demo, all of the databases are on the same instance, but imagine they're different versions, they're different instances of SQL. So we've got a sample database called Chinook, and we've got an SSDT project. So the first thing really is to get your code out of the database into text files. So we create a new SSDT project. So all we do is we right click on the project, and we go import database, we choose a connection, and then we start the import. And what this is going to do is it's going to take all this table definitions, all the store procedures, and it's going to pull them out of the database and put them onto the file system. It won't take too long. Now, if later on you're not going to use SSDT to do your deployments, but maybe you're still going to use SSDT to do your development, then use whatever tool it is you're going to be using to put the code back into SQL, to get the code out of SQL, because there'll be some slight differences in the way it formats stuff and things like that. If later on, maybe at the moment you're using Redgate's, what's it called? Redgate's SQL compare to do your deployments, and then you move over to this, just do a sync back from the database once, and then you'll basically be in sync and get all those differences. So we see now, pretty simply, I don't know how well you can see. Can you see it at the back on the screen? So you basically have all your files there. Now, first time you get your code out of the database, I pretty much guarantee you, because it's happened every single time I've tried to do it, you go and build your code, and what you'll get is it probably won't build. Okay. Now, there's two common reasons why code won't work when you first import it from your database. And people they go, you know, I've tried to use SSDT, I got out of the database, it doesn't work. That's it. I'm never using it again. I'm going to go and do something else. But the first reason is you need to have database references. So if you've got any code that references a cross database call to another database, what SSDT does is for each query you have in store procedure or function, each code that references another table or references something, it validates that it is correct. So if you've got select A from B, it validates you've got a table called B, and that's got something that's selectable called A. If you've got database name, schema, table name, it goes and validates that does actually exist and it is correct. And so if you haven't got those other databases in SSDT, and they either need to be in the project or they need to be sort of compiled to that pattern we're talking about, then it won't be able to validate those references, so it won't be able to tell you if the code's correct. So there's an overhead to doing this, and it is a bit of a pain. If you've got lots of database calls, lots of cross-database calls, and you're sort of referencing each other, then do what you can to start to try and move away from that. Like, you can get it to work in SSDT, and so in SQL Server, what you can do is I can have database A calls a procedure in database B, and the procedure in database B can reference a table in database A. Like, that's perfectly acceptable in SQL. But with the sort of the project system of SSDT and like the MS Build project system, you can't have circular references. So what you need to do in that case is you need to sort of separate some code into like a third project or even like a fourth project. So it gets quite messy quite quickly. So if you have got that, perhaps start on a database that hasn't got so many of those sort of cross-reference calls if you can, right? Because you will find it a bit of a challenge. But it is possible to do. So with the database references, there's 4 types. So there's this type. So you basically say this stack pack or this references project is actually in one database. Right, and this actually gets really cool because what we can do is later on we're going to talk about tSQLt. Does anyone use tSQLt? 1, 2. Does anyone write unit tests for a SQL code? What do you use if you don't use tSQLt? You just make stuff up. Okay, cool. So we'll talk about tSQLt a bit later on, but it basically gives us a nice framework for running the writing tests. Right? And it's really useful. If you do nothing else, go and look into tSQLt afterwards. So what we can do is, back in our project, we've got our database code, our production code. We'll have a separate project that's got our test code, because we don't want to later on, we don't want to deploy our test code to our production systems. So we keep it nicely separated in Visual Studio. And we can use this reference to say, this other project's actually in the same database. When I talk about tSQLt stuff, I'll show you that, because that's really useful. Then the second type of reference is a different database, same server, which is basically a cross-database call. So you're calling database name, schema name, table name, or whatever it happens to be. And then different database, different server is for handling linked servers. So you can call a piece of code and link over a link server. And then finally, each version of SSDT ships with a copy of master and MSDB from all the versions of SQL Server it supports. So if in any of your code, you access sys processes or any of the system views or functions, then you just have to add to a reference in the system database. So the first thing is, once you've exported your code, it's in your SSDT project, have a look, see what it's compiling. If it's referenced to another object or like a system catalogue, then you just need to add the right kind of references to it. The other reason is a lot of databases have broken code in them. Who's got broken code in their database? Who's actually got broken code in their database? I'm sure there's more than that. It's with C#. If you write a C# app, called a method, the signature check, and you delete the method and you try to compile it, it won't do it anymore. So you're wasting time, you can't deploy it. With SQL Server, you can create a table, you can create a stored procedure, it references it, then you can change the table. The stored procedure might have been an import routine from like 4 years ago. It's sitting in the database and no one ever uses it, so it's never a problem. But now you're exporting it, and now we're validating all the references and validating everything's correct. We suddenly find that actually the code doesn't work. So to be honest, the easiest thing in this case is just to have a look at it and say, this is a thing we used 3 years ago, we don't use it anymore. We'll just check everything into source code as we export it from SQL, so we've got a copy of it, and we'll just start deleting the code. Just have a real clear out, get rid of anything that you don't want. Because even though you think, I'm not going to start deleting code, that's ridiculous. But first of all, you've kept it into source control, so you've got a copy of it should you need to get back to it. And second of all, if it's ever called on SQL, it won't actually run anyway. You'll just get a runtime exception. So you might as well just delete it. No one wants it anyway. So what we'll do, so we've got this project down here at the moment. You see there's 4 layers, so it's not actually building. So the first thing I need to do is I just need to add a reference to on the system databases because it's using sys files. So the first thing I do is add a reference to system database and just say master. And then if we build that, we should start getting less errors. There should be a couple of errors still. That's built. Now instead of there being 4 errors, now there's 3 errors. So if you have a look at the errors, it's because we've got the store procedure. Reference to the table called update year-end status. Right? Probably shouldn't get rid of it completely, so check into source control, tag it so we can always get back to it, and delete that. Store procedure. And then if you build it, you should get a successful build. Perfect, cool. So 2 projects have succeeded and that's worked. Now, so we have got our code now building in SSDT. That's not all of that's not the whole thing. That's not the whole solution. So we've also got this reference data that we need to deal with. So when I talk about reference data, it's like static data or anything that's non-business data. So maybe you've got an employee type table. So an employee type 1 is a full-time employee. Employee type 2 is a contractor. So you have it in your database for referential integrity and to make sure that the values you're getting in from your app code is correct. It's this sort of reference data that needs to be part of source control, because you can't create a new database from scratch ready to put business data in if you don't have this data. You can't insert an employee if there's no employee types. So there's a couple of ways we can deal with it. So with SSDT you get a choice of scripts you can add to the project. So you can add these pre-deployment scripts and post-deployment scripts. And so what happens is these scripts you can just put in any tSQL you want. You could back up a database, you could drop a table, create a table, insert into a table. And so what happens is when we have this DAC pack, we want to do a deployment and it's got a pre-deploy and a post-deployment script in it. The tool that we use is called SQL package, and that takes the DAC pack and it compares it to the database and it generates a list of changes. And it says, we need to create this table, drop this store procedure, create all these steps we need to do. And then it runs the pre-deployment script. So this does cause some confusion because people think that the pre-deployment script should run before we make all these decisions about what's going to happen. So if you want to make changes before the sort of steps are built, then you just need to run your own script before SQL package ever runs. So now we've run our pre-deployment scripts, which might back up some tables or set some data up as we want it. Then the changes are applied to the database. So, those tables are created, store procedures are created. And then we have a post-deployment script. The post-deployment script is a perfect place to put scripts in for your reference data, your static data. Now for me, the easiest way is to create, put in a load of merge statements. So who likes merge statements? Who hates merge statements? Did you like and hate them? That's good. So merge statements are cool. So what they let you do is they basically have one statement and then you put the table, the contents in the table. So ID 1 to be full-time employee, ID 2 to be whatever. And then every time you run it, there's this thing called idempotent, which basically means you can run it over and over again and you end up with the same results in the table. So what you don't have to do is start thinking about, we've got first release is going to go out with the first script, and that's going to insert 5 entries for one for the employees table, and then I'm going to do the release next week. Has that script already run or not? Just put all your reference data, load of merge statements, and every time your script is deployed, the ending table will look the same. It will be as you want it to be. If you don't use merge statements, you're going to have to use if exists, check whether the row exists, and then maybe if one of the rows changed, you're going to want to update all the rows, and then you're going to check if there's any that have been deleted from the script. It's a real pain. So just use merge statements. The syntax is quite verbose. So it's often easier if there's a tool called SP-generate merge, and then you basically give it a table, run SP-generate merge, and it will generate the merge statement for you, which you can just put into your code. What we'll do is we'll just do that quickly. I'm just going to add a post-deployment script. already got the merge statement here.
That's a quick question. You say it does the compare before it does the post, the pre, sorry.
Yes.
What about things like replication? That's the thing that I've been fighting over, where a replicated database has long triggers, long additional columns.
Yeah. And you basically need to disable all these, disable all that, disable all the triggers, and then let this run. But this will do things like if you've got like constraints on it, SSDT will work out that they need to be disabled. And so it will disable them for you before it goes and makes any changes and re-enable them again. But with replication, I haven't actually done it with a database with replication. The only place I used it recently, but with replication recently, we sort of had to move away from the implementation of what was before. It shouldn't actually be in. So, I mean, deploying to replicated databases is a pain in the tail. So, again, if you're going to start doing this thing, start with take one of your easy databases, get used to it, get a process working. I mean, this database, the simple database is like 10 tables in there. I wouldn't necessarily, you don't have to start with something simple, but give yourself like the best fighting chance if you're going to build the whole pipeline. Start with one of your easier databases. So all I've done here is I've just added a merge statement. This text sets that up. I'll just build that. So the thing to remember is that when you deploy a DAC pack, everything in your DAC pack is going to be deployed to a database. So if you put your test code into your main production project, all your test code is going to be deployed. Now there are some things to help you, so you can say actually, when I do deployment, I only want to deploy these certain things, but it starts to get quite messy quite quickly. So have all your test code in a separate project you can reference. And using this, the sort of this reference thing that I was talking about, what happens is the test project has a this reference to the main project. So if you want to run a store procedure, you just have to say exec like schema name, store procedure name, rather than having to sort of reference it in another database. If you want to insert some data into a table, you just insert it into the table, like table or schema name, or just table name. It just makes things a lot easier. And when we use tSQLt, what we can do is we can just add to tSQLt as a DAC pack as a reference to your test project. So when you go to deploy your test project, you deploy the tSQLt framework, the main production code, and the test code, and you do that on your test systems, maybe a dev server, maybe a CI server, and then your QA server. You only actually deploy the DAC pack for your production data. But if you don't structure your project in the first place to be able to do that, it makes it really difficult. So structure your projects nicely. So a couple of people use tSQLt. So tSQLt makes life a lot easier for testing. So one of the best things about it is it's got this thing called faking a table. And I don't know if any like app developers, if you've done unit testing, you use like mocking, if you mock objects, it's similar to that. So what it lets you do is you say, take a table, and then normally if you've got a table, it might have like foreign keys to a whole load of other tables. So if you want to create a test, you've got to say, okay, I want in the table, I've got to insert like 13 columns because it's got 13 non-null columns on this, and then I've got 7 foreign keys, so all the foreign key tables need to have entries in them, and maybe those foreign key tables they point to other tables. So just to literally test one store procedure, all it does is check one column. You've suddenly got to set up all this data, and so you spend a lot of time setting up data. And with tSQLt, what you can do is you can create a test that just you say, take the. We'll do this. So you say like exec tSQLt fake table, give it a table name, and it will take the table definition as you've got it, and it will create a new dummy table that hasn't got any of the constraints on it, hasn't got any of the foreign keys on it. So if you've got a store procedure that only references one column or 2 columns, you can then do an insert into the table, for a real insert into the table, and you can only put the columns that you need for your test. And so you don't have this like massively long setup time for just doing a quick test. And it also makes you think about it, saying, okay, this store procedure, what columns is it actually using? And so I'm just going to set up those columns. So you haven't got to set up your long setup, and also you're thinking more about what you're writing. So tSQLt is completely free. There's an add-in for SSMS. If you're still tied to that, you're not going to move away from it. There is an add-in from Redgate to make it easier. But it's pretty simple. Okay. So the next thing to do, we've got all our code, we've got some unit tests, it's all building, it's all nice, it's all good. Is we need to check it in. Okay, so I'm just going to check it in using Git. I think it's a command version of Git just because I'm happy with that. So that's now checked in, right? So we've gone from having a database the code is all in a database to getting it into SSDT, to make sure it builds, adding the references, and then checking it in. And how long does that be? With my authoring about 10 minutes. So it's not actually that difficult. So if you want to get this code and source control, do it. And obviously, I've already got a source code server set up. Most organisations do have one, even if the SQL developers don't. And the thing with to use source control, is it doesn't really matter what type of source control you use. Okay, so you can use Git, you can use TFS, SVN, anything. They all work exactly the same way. They'll give you exact same powers and flexibility, except Visual Source Safe. Does anyone use Visual Source Safe? Yeah, I mean, I worked somewhere about a year ago, and they wanted to use it on our team, and we refused and went to use TFS. And our team was good, and another team wasn't so good. It was last released in 2005, I think, so it's like 10 years old. So get away from source safe. Who here uses Git, TFS, SVN, Mercurial? Yeah, there's always one person who uses Mercurial. But as I say, they all do the same thing, and using source control, we start to get this stuff like, I've written a few articles for SQL Server Central on like removing things like comment headers and store procedures and putting in its place version control, source control. And always people in the comments, some people say it's a good idea, and always people complain about it and say it's rubbish. But it means you can start to do things like, you don't have to have this change history at the top of each store procedure that is always wrong. Has anyone seen a change history that's completely 100% accurate? It just doesn't happen. So stop doing that, start using source control, start trusting your source control and saying, you know what, this store procedure's changed, and I can tell you when it was changed and who it was changed. I might not necessarily know why it was changed, but I know a lot more than I know from a source control header. Sorry, a store procedure header. Right, so this now is really where it starts to get really fun, really interesting. Okay, so we've got our code in source control. It's no longer just on my machine. I'm not the only developer working on it. I can now start to collaborate with other people. You know, if we've got a database and I'm the only person who can ever write code for it, then when I go on holiday, I'm going to be called and I'm going to be asked to fix stuff. And it's really not a good place to be, really. So I want to remove this sort of code ownership from the database. So I want to say anyone, like, within reason, we don't want BI people coming and changing any of our code, but we want some. We want to be able to share our code, so let people collaborate. So the first thing we're going to do is we're going to go and create a build. So I'm using TeamCity. Does anyone use TeamCity or TFS? A few people use Jenkins. That's a common one. I used Jenkins about 5 years ago, and it was okay. I've used it recently; it's a lot better. So if you're looking at a CI server, I'll go far on many of them. They all do free versions for small teams. So a good way to get started. So what we're going to do is I'm just going to use TeamCity. Create a project. So I've got a project. I'm just going to add a build configuration. The first thing I'm going to do is literally just build the project. So I'm not going to worry about the full sort of CI pipeline for now. I'm just literally going to build the project. So it's going to be CI. I'm just going to tell it where to get the source code from. I'll attach to that. Cancel that because it won't do anything. Now, each CI server, all you need it to do is to download your code at a certain point and run some command lines. If your build server does that, it doesn't matter what you use. The first thing we're going to do is we're just going to say basically run the end build solution. going to say build projects. And what this is going to do is it's going to check out the code, the latest snapshot of the code, and it's going to compile the SQL files and the SSDT project into a DAC pack. And when we've got that DAC pack on the build server, we can start to do things like deploy it, which is really useful. Save this, we'll run that. That'll take a little bit of time to run, so while that's running, I'll just give you a few tips. Yes?
You might be able to answer this, but is that going to run your tSQLt unit test?
So it's not going to run our tSQLt unit test at the moment. Now, who's used MS Build before and written MS Build scripts? So basically, to write an MS Build script, you basically edit your project file in an XML editor, and then you can add in XML tags to do stuff in MS Build. So it's a bit of a pain. And if you'd added into that like an exec task to then go and deploy your test and then run the test, when you build it, that step would build it. But the easiest thing by a long way is just to leave that side of things in separately, and we're going to build up a series of steps, and each step's going to be an independent command line. So the first step is literally all you're going to do is build the project and end up with a DAC pack. That's all you want to do on the first step. Because once you've got the DAC pack on the build server, the code's been validated, like it's syntactically correct, and that's important with source control because two people can check stuff in and you can like delete a random line by mistake. Without building this, we wouldn't know we were doing that. So if maybe we decided to check in the DAC pack, we're missing out a whole step. So the first thing to do is not get too worried about it. We're just going to build the project. So and this sort of speaks to the first point really. Like if you're going to build a CI pipeline, like decide where you want to be after like a day, a week, like 6 months, and a year. You don't have to be on day one taking your database code and deploying it out to your production system. Right? If you go to your DBAs or you go to like your management and say, this is what we're going to do, like tomorrow we're going to have a complete CI pipeline. It's going to deploy to all our systems. There's going to be some resistance there. Probably rightfully, I think there'll be some resistance. So start off and say, in day one, if we can have our project building on our local machines, that's a good step. At the end of the first week, if we can have it building on our CI server, that's a great step. And then at the end of in the next week, we're going to have the code deploying to a test database, running the unit tests. That's we're starting to really get somewhere. So just having your head where you want to get to in this, start small and just start improving it over time. Now, a second sort of major thing is a lot of people don't want to install Visual Studio on a build server. And for me, it just makes sense for two reasons. First of all, you've got all the dependencies, and it is possible to build, they call it a headless CI server with SSDT, so you don't have to do it. But it takes up a lot of time, and it's error prone, and it's not very easy. So the easy thing is just to install Visual Studio. And then I've been building CI systems for about 10 years now, and about 3 times I have not been able to figure out why the build's not working just from the build logs. Like something's gone wrong and I literally cannot figure it out. And the only way I figured it out is to open up Visual Studio on the build server, push build, and you normally get like a license dialog box come up or something like that. Like, you're never going to find it without actually building it on the server. So it just makes life a lot easier if you can just quickly go and build it on the server, make sure it builds there. So moving on to the third point, if you can't build it in Visual Studio yourself on your build server, you're not going to build it via a command line on the build server where you can't see anything. So when you're setting up a build server, you say, okay, we're going to set up Jenkins, whatever it is, just build a project on there, make sure it deploys, because maybe your test database is on another machine, maybe it's not on the CI server, it's more than likely not going to be on the CI server, maybe the ports aren't. I mean, that's a pretty common thing to happen. So make sure you can build and deploy from Visual Studio. And finally, I normally have like a batch file to drive the deployment because the deployment's got lots of arguments. You don't want to have lots of arguments. I should have turned that into Jake, I think, but I'll think about that next time. So, now let's have a look, see if our build's finished. Hopefully it's completed, yeah, it's successful, okay? Now all this has done is it's literally just built the DAC pack. But that's great, because without SSDT, the code's not being validated, so we know the references are all correct. We know there's no syntax errors in our SQL. We haven't accidentally deleted the where out of a where clause. that's good. That's a good first step. So the next thing we want to do now I said like creating the build is the fun thing, but this is where it gets really exciting. Right? Okay, now I know it's after lunch and people might want to drop off, but stay awake for this one, okay? So what we want to do is we want to take our DAC pack which we've built, and then we want to deploy that to a test server. Okay, so on our test system over here, we've got so I've got a number of databases. So I haven't got a CI database. So I haven't got a CI database. So when I deploy it, it'll create a CI database for me. So, but I want to deploy to this database. I want to take all the code. I want to put the tSQLt framework on there. I want to put on my unit test, and actually, you probably want to put on the production code as well. So what I'm going to do is I'm going to create a build. It's going to be a further 3 steps. So what it's going to do. I'm just going to take this. What I'll do is the first step will complete, the second one will fail because in one of the tests I've actually put a logic error just to demonstrate it. So I'll just set this up. Now, to deploy the code, we use this tool called SQL package.exe. And what this does is it just takes the backpack, compares it to your database, and say it runs like pre or post deployment scripts as well. Just makes your database in sync with your backpack. So we can say SQL package. I've got a whole load of arguments here. We can basically just say publish the changes. Then the next step we're going to do is once we've deployed the changes, is we're then going to run our unit tests. And to run our unit tests, I'm just going to say run SQL CMD. Everyone heard of SQL CMD? SQL CMD is a great tool. And with that, I'm literally just going to say log on to the local server, it's the database name, and run tSQLt run all. And this will find in your database, it will find all of your unit tests. You don't have to say run this test and run this test. Just go and find them all, run them all, make sure they all work. And if they fail, this step will fail and it won't move on to the next step. Then the final step we're going to have is just to where. For the CI build, what we want to do is we want to deploy our changes to the CI database so that we can run the unit tests. If we don't deploy our changes, running the unit tests is going to make no difference no matter how good or bad we make our code. But we don't necessarily want to deploy all our changes to QA or to production. Instead, what we want to do is we want to queue up the changes and want to generate the deployment scripts. So, the same about earlier, a deployment now becomes, instead of like, oh, I've been emailed a script over there and I've got Skype a script over there. Deployment now comes, hey DBA, we're going to release build number 47. And the DBA goes to that folder, gets the script from the QA server, and he runs it. He gets the script for the production server and he runs it. And I worked recently in our team, we were using CI and we had this sort of process. And the team next to us, they weren't. And the person doing the release went off to the DBA and he came back a bit dejected because he told the DBA, can you go and run these 20 scripts in the specific order? And the DBA said, no, I'm not going to do that. Can you go and merge them? And he was quite upset about this. So we spent the next day and a half merging these scripts for the DBA to go and run. And it just sort of goes to show, like, why should the DBA have to go through this list of 20 scripts and sort of find out which one should I run in which order? And when he's putting them together, he found a load of problems with them. So it's just going to show that if you can do it this way, and it seems easier, it was easier for him just to create 20 scripts, it was actually a lot harder for everybody else. So what we want to do is we want to generate the deployment script. So what we're going to do is we say we're going to use the package again, but instead the second time, instead of actually running the deployment, what we're going to do is we're just going to build a script for the QA database, and we're not going to do anything with it other than just leave it in the folder. So what that's building, we'll just talk about the interesting things. So as I was saying, so in tSQL package, you take your DAC pack, you're going to drive it with PowerShell or Batch because this here is a whole load of arguments, you're not going to want to type them in each time. And for the dev and the CI build servers, we're going to just push our changes out. We're just going to push them straight away. Now we've got a seat of our pants, pushing changes out. With QA and prod, we're just going to generate scripts. This means that a release is now really simple, but it also means is that if we've got one DAC pack and we're deploying it to different environments, there's a risk that maybe production has a store procedure that calls a link server somewhere else, but in dev we have some other code. We've got environmental specific code. In different environments you do different things, so you need to be aware of that. If you are doing different things, try and move it into a table and have a different block in your post-deployment script to deploy your different code for different environments. But that is something else to be aware of. You've got effectively now you've got one source of data going to different databases, and whose databases in dev, QA, and production are all in sync. Aside from changes you're currently working on, whose are basically in sync. Yeah. So it's not everyone in the room. Often dev databases, QA databases, they get refreshed every now and then, but they might have some genuine reasons why they're completely different to production. You start using this sort of automatic deployment, and now they're going to be in sync. You're going to know about it whether you want to or not. So just bear that in mind. And it's a good thing. You don't want your databases out of sync. You want them in sync. You want them the same. Because when you're testing, you want your testing results to be the same. If your databases are different and out of sync, then you're going to be getting some different results. So it's a good thing, and it's sort of pushing you down this sort of line of doing things properly. So we've got our build. Now we're getting close to the end. We're doing some really cool stuff now. So we should have, we'll have a look at it in a second. The DAC pack should now be deployed to a test server. We're running our tests. If we don't have this step, if we don't have any unit tests, we don't know that the code's good other than it's syntactically correct and the references are correct, right? And that's great. But like in this project here, what's happened is that it's all syntactically correct, but I've got a unit test that fails, right? And it's because the logic in the store procedure is wrong. So it's really important that you have this step and you have unit tests, because it's perfect to have code that works and compiles but doesn't actually work. So what I've done here is this, the first step is to compile the code, the second step is to deploy it. It's found in the third step, which is the run test step. So we have a look at this, we have a look at the build log, and we come down and say, this is the command that's failed, and it's run one test and it's failed one test. Then we go, we'll do some investigation, we're going to have a look at it, then what we'll do is we'll fix the code and we'll just see the build working, just because we've got to get cheer for some reason. And this is the perfect one. So there's just one quick thing I always forget to do is set up on my demos the trigger. So when you have a build, what you can do is you can trigger it different ways. You can either say, what we're going to do is we're going to trigger it. We're either going to trigger it every day. Now we might have a nightly build that works at like 12 o'clock every night that builds, or we're going to trigger it when someone checks in. We're going to say we'll set up a trigger, when someone checks in code, we're going to go and do a build. Save that. And we go back, we have a look at the code and you go, right, this test is failing. Why is this test failing? Because whatever it is, business reason, this should have been a 0 instead of 1. Validate it, save it, check it in. And what we'll do is, instead of using Git command line, Git's really good integrated into Visual Studio. That's another thing with Visual Studio is you get all the integrations you get with other development environments. Does anyone use ReSharper? So ReSharper's got this cool thing to do like Control-N if you've got the correct shortcut set up. You start typing a name, it will take you to it. So especially if you've got a large project with hundreds of objects in, hundreds of tables and store procedures, it can be a bit of a pain going down and finding stuff. So you can use ReSharper just to do Control-N, start typing the name, it does like auto-complete to take you down. It's a great feature, I definitely recommend using it. And it's the sort of stuff you get that's not been coded for SQL specifically, it's been coded for Visual Studio and you get it for free. So what I do now is I'll just check this code in, get that. So, right, button number. So what we should start to see now is after a little while, this will start to build. It's not like a 1 minute poll or anything, so this will either be really boring for 1 minute or really exciting. While I still have this middle. So we're now running the test, we've got a test run, and sometimes things go wrong, you know. So we run the test and it's broken the build, right? So if you break the build, you know, it can see, no, I've done something wrong, I've broken something. Breaking the build isn't a bad thing, it's a great thing. I'd much rather, like my unit test there failed because I had a logic in my code, I'd much rather it failed on a CI server rather than in production, hearing about it like 3 weeks later. And you know, that's a big problem. So, you know, it's not necessarily bad to break the build, so don't go, oh, he's broken the build again, he's rubbish, get rid of him. You should cherish him, go, yes, he's broken the build again. But also, you know, you've got to fix the build. If you break the build, fix the build, right? And if the build keeps breaking, if you get intermittent failures and stuff like that, just find out what the root cause is. Don't just leave it, right? Just live with it, because you'll find you'll start to get issues going into production. So it's always important when you've got a build, you keep working on it, and it's about, you know, continuously improving things. It's called continuous integration, but it's actually, like, for me, it's like continuously improving stuff. Like, let's get this process in place, and we're not doing that much today, but we're doing a hell of a lot more than we were yesterday. And you know what? Tomorrow and the next day and the next year, look how much we could do. So winners break the builds, winners also fix the build. But if you get somebody who keeps breaking the build because they don't run the unit tests on their machines, they're not winners. Tell them to run the test before they check it. Right? So we should have, still running now, so it's on the final step now, so it's on step 4 of 4. And what we'll see is, that it's been deployed to a database. We've got the unit tests have been run, and now what we end up with is a SQL script that our DBAs can run. We're deployed to QA, and see the time 2:15, so it's just been created. There's no magic going on here. And we can take this, and if we want to, we can just run this straight against our QA database. You can see here it's got no tables, but this could have a whole load of different tables in before we run it. Now got script run it correctly. Creates a database, and now we can refresh the tables, and you can see all the tables are there, but none of the test tables are there. So none of the test codes. So this is really where we want to be getting to. And you can get to this quite quickly. That's good. No, that's all good. That's good. That's all good. So that's basically what I've got to say. I'm going to put the slides up on there. That's my blog. If you subscribe to it, you'll probably be the 3rd person to ever subscribe to it. I'm going to take the 14th person out to dinner. Right? I haven't told my wife, but I will do. Have a look at there. This is about SQL Relay. I've enjoyed today. Has everyone enjoyed today? If anyone's thinking of doing a talk themselves, obviously the rest of them are sold out. If anyone's going to do a talk themselves, definitely submit, come along and talk. It'd be great to come back next year and someone say, you know what, I heard this funny bald man say we can build a CI process. We built a CI process and this is what it looked like. We didn't do anything that he suggested. We did all these other things. That'd be cool. Right? We'll do this and then obviously got sponsors. So, is there any questions? Yes?
Is there any reason you've chosen tMCT over the Microsoft Release Management tool?
No reason at all other than I just downloaded it onto my machine. So each build server basically does exactly the same thing. They've got a checkout code, they build some steps, and then they've got some other set of features on. So it doesn't matter what build server it is.
Just one of the other things we got is quite SQLt job.
Yes.
Really. And I've not found a way of doing that in here.
No, so SSDT is literally for deploying the database code. So anything from managing servers is a bit of a pain, but the best thing you can do is manage it inside posting on scripts. That is really all you can do for managing other modules. No, you're not going to do it. Yeah, so it's the question about like tSQLt or whether you write tests in tSQLt or your code itself.
Yeah.
It really depends for me on what team is doing this. If you've got a team of SQL developers and they're not writing a unit test or an test test, then I'll use tSQLt. But if you've got a team of like C# developers who are just writing a unit test, leave them in there. Do your code there. Don't try and make it difficult for yourself. But I would look at tSQLt even in that case, because you might find like breaking out tables is such a benefit. You want to start doing it. Yes. Yeah, potentially. Yeah. I mean, it's. I mean, I suppose the thing with like going back to the question about what build server to use and what test to use. Use whatever's in your environment. Use what you're used to. Don't start trying to break. Don't start trying to change things and going. You know what? All of a sudden we're going to. Everyone else uses the tMCT. We have to use TFS. Right. Just make life easy for yourself.
So actually, just in response to the gentleman earlier, we've got SQL jobs scripted out as well. It's working successfully.
Yeah. I mean, you've got to do it basically manually, but it's. I mean, that's right. Okay. Any more questions?
Do you have permissions between different environments?
So what I do is I don't handle any permissions across any different environments. I basically say that the permissions are completely separate. When you deploy a DAP pack, it will try and delete all your permissions. So there's a filter you can add to your deployment. If I wrote it, you can get it, you can write your own one. You basically say don't deploy permissions, because otherwise you get in a situation where, you know, in your code you're going to have like service account names and that sort of stuff. And it doesn't really work. So just remove it all from it and then just manage them separately as you mentioned today. You can, if you want to, you can do that sort of thing. It's often easy to change it. I mean, if you to manage permissions in SQL really is about creating roles and having groups in Active Directory, and that's how permissions should be managed. It's one of the areas that's quite tricky to do. There are ways around it.
Just another comment on earlier you were talking about why the role fails.
Yeah.
When I was doing this last week. So,
Okay.
one problem I encountered is that when you start the database out, it has a target database engine.
Okay.
Some properties that doesn't pick up the database engine that you were sending earlier.
Okay, yes. So each project, when you build it, it targets a version of SQL. So you need to go and set that to whatever version of target. I think if you have like latest SSDT, it targets 2014. So when you go to build, it will come up and say it's an incompatible version. There is a checkbox you can check in the options. There is an option you can set to say allow incompatible versions. If you add a reference to a DAP pack from a different version, it will sort of seem like it works. It doesn't work. It's a pain, royal pain. So don't ever do that. Okay. We are sort of out of time. If anyone's got any more questions, come and grab me. I love talking about this stuff. Thank you.